Hi, and welcome to the project of Stephen Littman, Ava Liu, and Maggie Parkhurst-Bartel. For this project, we had to design a robot with a platform that had the ability to move around a room and avoid obstacles, as well as an arm that could reach out and move around a 3D space surrounding the platform. We used forward kinematics, inverse kinematics, platform trajectory generation, arm trajectory generation, and static balance control to do this project. Here we have forward kinematics. This section allows us to be able to choose different angles and have the arm move in a different position based off the angles we've chosen. Here we have inverse kinematics, where we're able to choose a position and have the arm do inverse kinematics to find the angles for each joint in the link. You can see as we choose different positions for all these values that our angle values in the forward kinematic sections are also changing. Here we have platform trajectory generation. This section generates a trajectory for the platform so that it can move in any position of the surrounding XY plane. Its initial position here is at point 400, 400 with an orientation of 135 degrees. The demonstration will show a trajectory of the platform moving to the origin and returning to its original position and orientation. Here we have the trajectory generation for the arm of the robot. This section generates a trajectory for the arm to move in any of the surrounding 3D space around the platform. The length of the arm of the robot is 100 centimeters long. Here we have set it to go to 2020 in the XY plane and then 4040 in the XY plane. If we extend our robot too far, we'll set this to 120 in X and 120 in Y, then the robot's platform will move to a location that's closer that will allow the robot arm to reach it. Here we have the static balance section. This section checks to see if the mass at the end of the end effector is too large and will cause the robot to tip over. In this project, we have defined the mass of the base of the robot to be 5 kilograms. The mass of the sensor can be changed by the user in this section here. If this check mark is displayed, that means that the robot is at risk for tipping. When we set it to 0, we can see that there is no mass and there is absolutely no risk of tipping. When we set it to 500 grams, we can see that there is still no risk of tipping for the robot. We can see that once we have set it to equal 700 grams, that there is a risk for tipping, which is shown here.